Welcome to the first video in this three-part series on working with legacy code. We're going to showcase in this first video a particular refactoring technique called breakout command object. It's also called breakout method object or replace method with method object, or replaced function with command, depending on which book you're reading. This particular technique is talked about in the excellent Working Effectively with Legacy Code book by Michael Feathers, and the Refactoring, Improving the Design of Existing Code by Martin Fowler. I'll post a link to both of these excellent books in the video description if you want to pick them up. Now, this particular refactoring technique is a technique that's used when you're working in or you need to make some changes in existing code that is hard to work with. Usually you'll use that technique when you're trying to change some code in a long function that's contained in a very big class that is complex, has a lot of dependencies, all of which makes it really hard to bring into a test harness. Right? And the idea or the philosophy we're starting with is that we don't want to make any changes to our system unless we have the safety of tests in place first. Now, what do you do when you need to make changes in a class or in the method that is hard to bring into a test harness? Well, that's when you use that, a refactoring technique like the one we're about to showcase. And what we're going to do, this technique gets you to do basically, is to extract the code from that particular function and put it in a new class. And you do that in a very safe way. And you have to, because you don't have tests in place to make sure that you didn't break anything. But being methodical and using the compiler, your IDE, you can do that in a very safe way. And then you end up with a very small focused class that is just basically a wrapper around that one public function. That's what we call the command, right? A command object. And that is much easier to test than this potentially, really big, long class that you have to try to bring under test with stubs and mocks and all kinds of stuff, right? So we're going to be seeing how to do that in just a minute here. I want to give you an overview of what we're going to be seeing in the next videos as well. The second part of our three-part series is going to be actually writing tests. We're going to be writing what I think Michael Feathers in his book, Working Effectively with Legacy Code, calls characterization tests, right? So when you're doing TDD, right, test first development, you usually write unit tests that describe what you expect the system should be doing, right? The correct behavior of the system, right? And then you write your implementation so that those tests pass. Characterization tests are tests that you write for an existing system to basically document what the system is doing right now. Not what you think it should be doing, not what you think the correct behavior of the system should be, but really just documenting what the system is doing right now. And that's to give you a little bit of a safety net for your upcoming work, your refactoring, your new implementations, your changes, so that you can be confident that you're not breaking something without realizing it, right? So that's going to be part 2. Part 3, once our tests are in place, is we're actually going to be refactoring the code, and we're going to be doing the work we came here to do in the first place. Now that brings me to what exactly is that work? What are we trying to do today? We're going to be using an actual real-world example in a real application. There's this bug ticket I need to work on, and it's a pretty simple one, so it's a good candidate for what we're doing here. But it's located in a part of the code in the application I've never worked with. It's in a form I've never really played with much. I've never really worked with that part of the code, and the code is real legacy code. You're about to see why in a second. But first, what is the bug? Well, it's centered around this field here, right? Date of birth. It's a date picker. If we select, for instance, yesterday, let's do that. Well, we're going to get this message here. Age must not be less than 18 years, and we get this invalid date label. So although I don't know all the business rules for this form and this field, now I realize, looking at this, that, oh, okay, we're expecting whoever's filling out this form to be at least 18 years old, right? It can't be a minor. And obviously, if they're born yesterday, we've got a problem, right? So fine, everything looks good so far. Now, the bug that's been reported is that if we do this, and now we get an invalid date label, and we, realize that I'm not 1 day old, I'm actually 40 years old. And now we change things to say, 1980. Oh, still shows as invalid. So is it a validation issue? Is it just an update of the label issue? I don't know, right? I don't know. That's what I need to find out. That's what I need to correct. That's the work that needs to be done. Probably not that complicated. Certainly wouldn't be if the code was really clean and easy to read, but it isn't, right? And that's what makes all these fun refactoring techniques necessary. So let's take a look at this. Ahead of time, I've looked at the code a little bit, used the debugger to pinpoint the piece of code that we're going to need to work with. And it's in this UI component. It's in an Angular app we're going to be working in today, so using TypeScript. If you've never used TypeScript or Angular, don't worry. We're not going to do anything that's Angular specific today. We're going to be working, we're not going to be working with HTML or CSS or anything like that. All our work is going to be done in TypeScript, which is super similar to C#. If you're familiar with C#, TypeScript is pretty much the same thing. It looks very similar anyways. And Java as well, right? So you won't be lost at all. And what you'll see today, you'll be able to transpose and use in your own code base. So don't worry about the whole TypeScript Angular thing here. So this is the only time you're going to be seeing HTML, because we're looking at the template. This is running after all in the browser. This is the part, right? See, date of birth and the date picker. Now, what we're interested in is this. We're interested in this. On date changed is an event. That's, what we do on that event. What do we do? Apparently, we're assigning the event value to this date of birth property on this object. But also, and this is what we're really interested in, we're calling this function and passing in false. All right. So I've determined that validate birth date in the associated TypeScript file is what we need to look at. Validate birth date. Yes, that's it. Let's get there. There we go. So this is the function that we're going to be working in. And just a quick look at it. First of all, that's far from the worst function I've seen. It is longer than I would like it to be. It does way more than it should. It's not very focused. It's at different levels of abstraction. There's a lot, legacy-ish about this function that could be refactored and changed and improved. But it's far from the worst I've ever seen, right? But you can tell that it's dealing with dates. We're creating new dates here. Already that should be a no. Depending directly on the system clock is not great, hard to test, right? So that's something we're probably gonna want to change eventually. We've got this date picker components thing. We've got the flash message service. So I've seen that, right? We saw that on the screen. So we can tell that this says, all right, so this is like a condition. It's pretty complex. I'm guessing it checks that the date is less or more than 18 years. And we're setting some variables. We're flashing a message. We're looking for some date picker. And now, interesting, we also see that there seems to be validation for, we don't want people older than 125 years to fill in this form. I'm guessing, right? Oh, well, there you go. Yeah. Age must not be more than 125 years. All right. And we're calling this other function called validate dates. Now that's interesting because we're actually validating the birth date here. So why would we need, when we change the date in that date picker, why do we need to go and call this validate dates, which I'm guessing is validating other dates, but I don't know. Like I said, I'm not familiar with this code, and yeah, this will be interesting. So, okay, so what we're going to do is we're going to use that breakout command object refactoring technique to move that code out of this class. Why do we want to do that? Well, I'm glad you asked. Look at the associated template for this component. 2,000 plus 2,300 lines of HTML and over 1,200 lines of TypeScript. And if you look at the number of instance variables in that class, it's insane. I think it's got like around 80 instance variables. Those are all instance variables. Now we're getting to the constructor. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 dependencies injected in the constructor, and probably a bunch of stuff that we depend on directly without being injected through the constructor. And all of that compounds to, a really hard to test class. The bug seems to be really simple. It wouldn't make sense at this point in time to spend hours, possibly days, trying to bring this class into a test harness, mock or stub all those dependencies, and not worth it, right? So what do? We break the code that we're interested in out of the class. We liberate it. What was the name of that function again? Birth date? No, validate birth. Can't type. Yeah, that's the one. Okay. First step. Actually, before we do that, I just want to say that depending on your language and IDE, you might have the tooling to kind of automate large parts of this refactoring. There might actually be a, replace function with command object, or replace method with method object refactoring that's already built into your IDE. It's not the case for me today. So we're going to be doing this manually, which will, all the better. It'll be easier to see exactly what this refactoring does. The first step is to create a new class, right? So let's do that. We're going to be doing that manually. We're going to be calling it birth date validator, right? The function we're breaking out is validate birth date. So I'm making a class out of that. Birth date validator makes sense to me. Can always change that later if we don't like it. Birth date validator. Now in TypeScript, classes don't have access modifiers. It's all public. But it isn't if you don't export it. We are exporting it. It means we can import it from other parts of our code. So it's in essence public. Or internal, I guess you could say. I guess it depends. All right, so we've got our class. Now what do we want? We want a constructor. And we're going to use our constructor to pass in everything we need to that class so that we can basically copy the body of this function here. The first thing we need is to make sure that we have access to all of the class dependencies in here in our old class. So we see a lot of this, right? Which makes it easy to see all those class dependencies. There's a few of them. We need this applicant common model. That's a variable. This is a variable as well, a Boolean. What else? We've got the state picker components thing, which I'm not query list custom date picker. Okay, we'll look into that later. That flash message service. We're actually calling another method, right? So there's a lot of stuff from this class that we're going to need to carry along with us into this new class. So what's the best way to do this? Well, a very simple way to do this is to pass in a reference to this current class into our new class. So we're going to start by passing in, we're going to call it component because we're basically passing in an instance of that component. And it's of type applicant personal info component. That's the one. Now the next thing we're going to need to pass in to make sure we've got everything we need for this function is the final validation parameter. Now this was the function parameter. We're going to pass that into our constructor. Let's use the exact same name. That makes it easier if we're keeping the signature like that. All right, so now we have what we need to kind of prepare the moving of the function itself. Now, traditionally, command objects will have one public method called either run or execute, so we can definitely use that. But now that I'm thinking about it, why don't we just call it validate? That's what it does, right? That's a birth date validator. Execute or run would be fine as well, but I don't know. I just feel like going with validate. Okay, and now we ready to copy this over? I think we are. Well, first, let's make sure that this is returning a Boolean. Okay, there we go. Copy and paste. All right, and our IDE, our compiler, is working for us and telling us, hey, we're missing stuff here, which is perfectly normal, right? Because it used to have these things available on the class when it was inside applicant personal info component. But now we don't have those. But we do have an instance, a reference to the applicant personal info component. So now it's just a matter of simply adding component in front of each of these. And I'm going to do them one at a time because it affords me the time to go through the code and look at what we're dealing with here. Okay, the date picker, we've got our flash message service. I guess we can just copy this like that. Okay, and that, like this, and okay, so this is our function parameter that we're now passing in through the constructor. So this can just be this and components. Now, one thing I forgot to mention, see, this went pretty well, right? Easy. And the reason for that is that all of these, it so happens that all of these, variables or method from the other class are public or public read only, whatever. They're public, right? They're accessible to us outside of that class. Because I guess whoever worked in it before wasn't big on encapsulation. Good for us, I guess. But if, for instance, a lot of those variables would have been private, we would, in that case, need to possibly, introduce a getter. That would have been one way to make sure we can access what we need. When it comes to the methods, if it was private, well, then you probably, depending on your language, probably will have to make it public, which is a compromise, right? but we're working with legacy code. If you're dealing with a class that's like 1,300 lines of code, and long functions, and it's tightly coupled, and it's a bit of spaghetti, making a private function public is probably the least of your problems. It's worth doing if it allows you to break out some of that code and put it on their test. But in our case, we don't need to do that. All right, so now we have moved over the content of that validate birth date function. Our compiler helped us do it in a safe way. There's no reason to think that we broke anything here. So let's go ahead and now remove the code from our old function in the old class. And we're now going to delegate to our new class. So let's first create an instance of our new class. We're going to call this Validator. New birth date validator. Okay. Now it's been imported automatically, but we're missing our two parameters. Oh, final validation any. Don't like that. Yep, forgot. Put the type as Boolean. TypeScript is a type language, but it's an optional type language, so it doesn't force you to type your stuff. But you should. Otherwise, there's no real point in using a type language. My opinion, anyways. Okay, so we're missing, what are we missing? We're missing two arguments. What are they? They are, right, a reference to our applicant personal info component. That's easy enough. This. And we're missing the final validation, which we can just pass in here. Now we've got our validator instance. We can go ahead and validate. Oh, right. We actually need to return. So this function, has side effects, but also returns. So that's another thing that's not great. But, for now, our job in this first episode, in this first video, is just to break out the code. We're not actually, improving it or refactoring it or changing it in any real meaningful way. Okay, so, and that's actually, everything compiles. Everything looks good. We didn't change anything. So we're essentially done. And just to confirm, maybe as a kind of manual test, that this is still working. Let's just refresh this. Take a sip of water while we're waiting. I don't know why this is taking so long, but okay, here we go. And if I was to put in yesterday as my birthday, all right, I still see that validation message, invalidate, and we can confirm that we didn't fix the bug. It's still there by setting a date that should be correct, 1980, and we still have that label here. But notice that we don't have a flashing message saying that it's not correct. All right, so doesn't look like we broke anything. Now, maybe one last thing before we move on to the next video and actually start writing characterization test. The astute viewer will say, well, wait a minute, Phil, you didn't really fix anything here, right? The reason why we're breaking out this code in the first place is that we are of the opinion that this class is just way too big. There's too many dependencies, there's too much going on, and it would be complicated and time consuming to bring it in the test harness. But now, yeah, we broke out the code, but we brought in the class. We are still depending on that very same large class that's hard to test. So did we really improve things? That would be a justified observation, but we're not quite done yet. There's one last little thing that we need to do to make our lives easier. And that's to break that dependency on the applicant personal info component. But we need it, right? We've got all these dependencies that are on the applicant personal info component. How can we not depend on it anymore? Well, we can not depend directly on it. We can use an abstraction, an interface, and narrow the scope, I guess, of our dependency on that component, and just depend on the stuff that we actually need from it. So we're going to create, I'm just going to do this in the same file. We can refactor that and break it out into a different file later. So we're going to create an empty interface to start with. And let's call it, I don't know, let's just call it date validator for now. And now there's a few different ways to go about this. But an easy one that I think you pretty much have out of the box in in every editor I've ever worked with is, not to manually go ahead and fill in the interface, but actually use the compiler or the language service to help you out here. So here's what you can do, right? Depend on that empty interface. Now, rightfully, the compiler will say, hey, buddy, date validator doesn't have these things that I need. So that's cool. Let's just use the editor and say, all right, add all missing members. Boom. And now we've got everything we need. Now, we're working in TypeScript. TypeScript's got optional types, and it's gone ahead and said, I don't really know what's the type of these here, so I'm going to put any. We don't want that. We want the actual type. So these are correct. That's correct. Let's just make sure we've got the correct type for the flash message service, which would be in the constructor. Flash message service. Okay. And import that. Date picker components. Now, what is that? Well, there's like 100 of them. I'm just going to do a date picker but there it is. Okay. Okay. Yeah. I'm not a fan of this. This is Angular specific. I'm not going to go too deep into this, but essentially what this does here, it's like kind of querying the DOM for Angular's version of the DOM for an element that implements the custom date picker component, which is a custom type of component that we have in our applications. And I'm guessing that this is what it returns. So it's a list of whatever it finds. And that's a class that's specific to Angular, right? So anyways, this is the type that we need. And that's what we're going to use. Date picker components. Need to import that. And finally, applicant common model. Okay, this is what it's called, applicant common edit model. There we go. Now, don't need this anymore. Okay, so we've got our interface. We're passing that in, and the compiler seems to be cool with everything. Now, maybe one thing I can just mention is that you might have noticed that I didn't actually have to do anything to our previous class, right? I didn't come here and say, we need specifically or explicitly declare that we're implementing the date validator. This is just an import. Oops. No. Oh, and this doesn't work because we don't have an export here. Okay. Now we can import it. There we go, right? So that would be the explicit way of saying, this This is like a contract. We're saying applicant personal info component must implement date validator. And in some languages like C# or Java, I think you wouldn't have had a choice to do that because the type system is kind of name-based, right? The compiler, if you're asking the question, at runtime, so I guess not technically the compiler, but whatever. If you're asking the question, does this instance of a class implement date validator or is of type date validator? If you don't have this kind of code, then the answer will be false, not true. But in TypeScript, even if you don't have that, since the type system is more like shape-based and not name-based, as long as the class actually implements the name and the signature and the return types of your interface here, TypeScript will consider that it's correctly implementing it. And that is why the compiler here is not complaining, right? Notice that if we go to our, birth date? No, validate birth date, this one here, right? Not complaining. It's completely fine with us passing in this class into our new class, even though we're expecting a date validator. And this class does not explicitly implement it, but TypeScript knows that it fits. It fits the contract. And here's the proof that it works that way. If we were to add a foo parameter of type string to our interface here, go back here, now TypeScript is like, oh, we've got a problem. This is not assignable to parameter of type date validator because foo is missing, but it's required in date validator, right? Pretty cool. I think it's a cool feature. When you're not used to it, it's a little confusing. But once you know how it works, it's pretty powerful. And there you have it. So yeah, I just wanted to mention that so that you don't forget that if you're working in C# or Java or whatever, you're going to have to go back to your old class and add, some sort of implement, that new interface. But now we're done. We can move on to the next video where we're going to be actually writing some characterization tests.